All right, guys, so I'm going to work on page 56, which is going to be a review of all of our special line segments. So if you take a look at that, I'm going to do the front side with you. And then I would suggest that you guys kind of try the inside on your own and then come back to the video and see if you did it right, because I think it'll be a good review for you. So first thing I want to talk about is a perpendicular bisector. So the way that I can tell that a line drawn inside of a triangle is a perpendicular bisector is I really have to look for two things. I have to look for a line cutting a side in half. So for instance, maybe I see two tick marks on either side of a line. So that's the bisector part. And then I also need the perpendicular part. So it's really two things, bisector, perpendicular. Now, it may or may not go through the angle opposite. The reason that it goes through the angle opposite on this one is because this is an equilateral triangle. That one always happen. Like on this one here, if I were to cut this side in half perpendicularly, the line would not go through the angle opposite of it, and that's okay. Another line that we want to be good at identifying are our angle bisectors. Now, an angle bisector, I really only have to look for one thing. I need to look at an angle and that it has rainbows on either side of it. So it could be drawn at any angle. So let's say, for instance, I draw something like this. I would know that it's an angle bisector because there are rainbows on either side, showing me that it's splitting that angle in half. Nothing has to happen over here where it crosses the other side. It doesn't have to be perpendicular or in half. The only thing that has to happen is I need to look at the angle and look for rainbows. As long as that happens, you got an angle bisector. Another one that we talked about were our medians. So with a median, kind of two things. It's a little bit perpendicular bisector and a little bit angle bisector, kind of. A median has to come from a midpoint and be drawn to the angle opposite of it. So if I find the midpoint of this side, I'll know that it's the midpoint because I'll have tick marks on either side. And then the line that I draw has to connect to the angle opposite of it. So it's got the bisector part like your perpendicular bisector, but it's not perpendicular necessarily. It might be. But it also has to be connected to your angle. So I'm really looking for cut in half and connected to an angle to know that I am a median. Another one that we talked about was our altitude. So I will know that I'm looking at an altitude if I'm a little bit angle bisector and a little bit perpendicular bisector again, but different things. So it's going to start at an angle, so like our bisector, but it's going to drop down perpendicularly, but not necessarily in half. So I don't think it'll cut this guy in half if I have to go down at a 90-degree angle like that. But it is perpendicular, and that's kind of it. So perpendicular connected to the angle, not necessarily in the middle. And then the last one we had was our mid segment, and I'm trying to like match up the colors here. And a mid segment is kind of unique of all of them. It's maybe a little bit midpoint or median-y because what I do is I find a midpoint on one side and a midpoint on the other, and I connect the dots. It's also parallel to the side opposite of it, which is super nice. So if I take a look at the inside of this, for 1 through 9, you're going to want to determine what type of line segment you're seeing. I'm going to zoom out just for a second and write that down. It might be more than one. So A, if it's an angle bisector, B, if it's a perpendicular bisector, C, if it's an altitude, D, it's a median, and you can list all that apply. So it might be more than one. And then for these 4 examples down here, you're doing a little bit of mathy stuff. So again, I might pause the video here try them out, and then you can come back and see how you did. Hi, welcome. Are you back? Okay. So number 1, I can tell is a perpendicular bisector because perpendicular bisector. It's also a median because it's connecting midpoint to angle. It's also an altitude because from the angle I drop down perpendicularly. And if it's like all 3 of those, then it's also going to be an angle bisector. And the reason that that happened in this triangle here is because this triangle is isosceles and it's going through the angle that is different. It will also do that in an equilateral triangle. Now, number 2, I can tell that this is just an angle bisector because of the rainbows. So that's A. Number 3 would be a perpendicular bisector because bisector, perpendicular. So that's B. Number 4 here is a median because it's connecting midpoint to angle. And really, it wouldn't need to go outside like that. Probably shouldn't. So D, median. Number 5, also median. Because we're going midpoint to angle, I can tell because of the tick marks. Number 6 is an altitude. That is C, because we're going from an angle perpendicularly. Number 7 is a perpendicular bisector because it has both perpendicular and cut in half. Also, it's not attached to the angle across, so it wouldn't be an altitude. Number 8, I can tell is an angle bisector because rainbows on either side. And then number 9 is an altitude only because perpendicular, and I don't know that it cut that side in half and it really doesn't look like it. So altitude only. Now, number 1 down here, that guy, this line, is a mid-segment, and this line would not be the same length as that one, so I can't really set them equal. But the thing that they do have in common is the small one is half the length of the long one, or I can double the small one and it will equal the long one. So you can either double 7x minus 1, or I could cut the longer one in half, which is what I'm going to do. So if I take half of 48, that's 24. And if I take half, then I'm talking about the mid-segment, which is also 7x minus 1. And so I would add the 1 for 25 and then divide the 7. And it's not pretty, but 25 over 7 would be what x is. Now, with number 2 here, I can tell that this is a perpendicular bisector because it is perpendicular. And I know it's super small, but these are congruent. And if that happens, if it's both an angle bisector and a perpendicular bisector, then it's kind of all of them. So that was like an example like number 1 up here. And so that would make these 2 things equal. So 5x minus 6 equals 3x plus 8. I think that's what those numbers are. They're really hard to see and blurry. I would subtract the 3x both sides and add the 6. So 2x equals 14. So x is 7. In number 3, I can see that I have an angle bisector because of the rainbows. So because it's an angle bisector, those angles are the same. So I can set 6x minus 9 equal to 4x plus 13 so that I can solve for x. And I would subtract the 4x both sides and add the 9 to get 2x equals 22. So x is 11. And then on the last one, they tell you straight up, it's a median. And in a median, D would be a midpoint. So those 2 things would be equal. Oh my word, what is that supposed to be? We're going to go 6x plus 3 is equal to 7x minus 1. And I would subtract the 6x on both sides and add the 1. So I would get that 4 equals x. I'm so sorry those numbers were so blurry. Hopefully that helps. And I'll see you later.